All right. I hope everybody's ready. So last time we implemented this Connect 4 program. And I don't believe we actually finished it because did we implement this tie function? I think I forgot to implement tie. And let's see, it probably doesn't even build. Yeah, tie was not declared, see? So I wanted to finish this up. For tic-tac-toe, you'll need a tie function as well. Okay, so you have to think about how to do a tie. And so we need that. I'm going to put it with these other functions. There's wins. We'll put it with wins. Okay, so if wins is pretty big, and ties, we're going to call ties. Is there a tie? That's what I call it, ties, right? So if, oh sorry, tie, not ties, just tie. If tie, so we want the expression to be like this. If tie, then print the grid, and then print the word tie. If you look at the main logic here, let's take a look at the main logic so we know what we're doing. The first thing we do is we initialize the grid. So we fill this grid full of dots. So when we render it, we have the data structure. This is important to review as well. Here's our data structure. The name is grid. It's a two-dimensional array of char, or character. A char is a single byte that is used to represent, it could represent any data, but typically it's used to represent a character. And this grid, the cells in this grid either have an X character, an O character, or a period character. Period means it's an open cell. The player can, or the computer can move there. Remember, this is the Connect 4. There it is right there. That's the grid, cells in the grid. There are 7 columns. There are 6 rows. You pick a column and you play in a column like this. Okay. Computer wins. So that's what the grid represents. It represents those slots in that playing area. 7 columns. That's the second dimension, and 6 rows. That's the first dimension. Here's the 6. Each of those cells has an X, an O, or a dot. There's a function to print the grid. Whatever's stored in grid, we're just going to display the grid. We'll see what it looks like. There's a function to initialize the grid. It just stores a period in every cell. So we call that once at the beginning of the game. There's a function that checks to see if a move is valid. So a move is where you select a column. And your disk will slide down to the lowest possible open cell. So is there any open cell in column C? Well, we look at row 0. Is there anything is the top slot open? If the top slot, if the top slot is open, we can move there. We don't need to know if there's anything below the top slot occupying those cells or not. That doesn't matter. If there's at least one slot open, we can make that move. So we only test for the top position in the column C that we're interested in. So we just return the result of comparing that top cell with the dot. If the top cell equals the dot, we know we can move in that column. It returns true that way. Otherwise, it returns false. If that cell is occupied with an X or an O, that comparison evaluates to false. and we return false. It's not a valid move, column C. And then we have a move function. So this is where we know in advance that column C is good because the calling code would have called valid move and got the go-ahead to move into C. At that point, we're going to call the move function, pass in the C, and the symbol, either with a player, in which case we pass in an X, or with the computer, we pass in an O. And so this code here iterates through the rows of that column C and finds the row, the first row from the bottom up, that contains a blank cell. And that's where we're going to move. That's where we're going to store the symbol. That's where we do it right here. This is where we store the symbol in the lowest possible cell in column C. So this loop is to search for such an R. So we start with R equaling 5. That's the bottom of our grid. If we find a dot there, that's where we're going to move the symbol. If we don't find a dot in row 5, we're going to check row 4. If row 4 has a dot in that position, RC, we're going to write the symbol there, and so on. So this function assumes that C is a valid move. If we were worried about that, we could just put an assert here. So that if we got the logic wrong in our code, this will catch it right there. So we're just calling valid move redundantly. We're calling it twice, but that's okay. This is good documentation, actually, to do this. The other thing about this valid move is we might want to improve this. So if C is less than 0, or C is greater than 6, and return false. So we want to make sure that C is the valid column number. You know, I'll forget about whether there's a dot at the top position or not. We want to make sure that C is good. So we can return false there, or we can turn that into an assert, which means that we have to enforce the user choice at another place in the code. So I know, because I wrote this code, I know that returning false here is going to work. So maybe I'll leave it like that. But it might be more easier to program if we turn that into an assert. Now I'll show you. Because this returning false here is it's sort of expanding the responsibility of this valid move function to do a little more than maybe than it ought to. It's better to keep the functions, their responsibilities narrowly scoped, narrowly defined. So we're not going to handle the case that C doesn't make sense. We're just going to handle the case that a particular valid column number has an available cell in it. So that means where we do the player move, that's where we would add the logic to make sure that C made sense. So let's suppose that we read in the player column here. So if the player column is less than 1, so remember the player numbers are different than the internal numbers. So the player is going to start counting columns at 1. It's going to count 7 columns. So we want to make sure that player column is less than 1. If it is less than 1, or if the player column is greater than 7, then we want to, then it's not a valid column. So we don't want to execute this stuff. So what we could do here is put in a continue. That means restart the loop. That's one way to do it. If you don't like continue, then you can do this differently. I like continue, but if you don't like continue, I'll show you an alternative way to do this. You could do it like this. If player column is greater than or equal to 1 and player column is less than or equal to 7, then we can move forward with this business. If the player column makes sense, then we can go ahead and compute the internal column number, check for valid move, and if it's valid, then we move and break. So that's another way to do it. So if we don't break here, if we don't move and break, that means to just repeat the loop. So maybe you like this code better than this code. I don't know. And there's even another one we could do. We could do it like this. There's another option. Oops. We could convert to internal column numbering, and we could do if player column is greater than or equal to 0. Sorry, if C is greater than or equal to 0, and C is less than or equal to 6, and valid move C, then we can move and then break. Maybe that's easier than this one, right? This is maybe this is a little easier because you see we have all of our sort of criteria together in a single if condition. If C is greater than or equal to 0 and C is less than or equal to 6, that means C is a meaningful column choice. And then we can pass C to the valid move function. That just checks to see if there's an open cell at the very top position of the column. So maybe I like that better. It's certainly fewer lines of code. I think some programmers don't like continue as well. We could put it like that. Oh, and this is something wrong with the indentation. See, I see that there's 2 indents here. So there's something wrong with the indentation. I can see that. What does this doesn't make any sense. You see that? I'm paying attention to my indentation. I could see that there was a problem there just by cleaning the code. I didn't check the logic mentally. I just checked the formatting. The formatting doesn't make sense. My indentation doesn't make sense. See that? See, why would there be 2 indents? Move is looks like it's a substatement of the if statement. So that means there should only be a single indent. So through that visual inspection of finding the mistake in my formatting, I could see that I had a logic error there. So that's, once again, my lesson on the importance of the style, code style, or the cleanliness of your code. And then here we have computer move function. We have the wins function. We did that last time. What about the tie function? How do we check for a tie? First of all, I'm going to assume that when we call tie, there's no win for X, and there's no win for O. I'll put that in there as an assert. Now, you know, that takes compute energy to carry that out, right? Because you have to go through all those loops. But so what? I mean, it runs so fast anyway. It's already on the level of nanoseconds, I think. It'll run faster than a microsecond, or a millisecond, rather, faster than a millisecond. So it just helps with the assuring that the logic is correct. So when tie is called, we can assume that, you know, that X is, we don't need to check for a win first. We're assuming that the outer logic will handle that. So that's a precondition to our tie function. So the tie function doesn't need to check for that. All right, so how do we do a tie? Any suggestions? How do we check for tie? How would you check for a tie? Assuming that X and O passed into the wins function returns false, so we don't have a win. What's the condition you would rely on to determine whether it's a tie game at this point with that precondition?
Wouldn't you have to think about it as like if every single period was removed and replaced with an X and an O?
Yeah, that's right. If every period was removed. In other words, if there are no periods in the grid. So what would the code look like to check to see if there were no periods in the grid?
Court marriage for lesbian and gay couples.
That's fun. What's the basic mechanical procedure you would use to check? Yeah, you'd use a for loop. Would you use 2 for loops or 1 for loop?
2, because there's rows and columns.
So you check every cell, right? But why bother to check every cell? Why not just check the top row? See? Because we slide the symbols down to fill up the bottom. So we only have to check the top row. So we need 1 for loop for that. So for, that'll be columns. So for C equals 0, C less than 7, plus C. Anyway, that was good. You got the idea there, for loop. But if we had nested for loops and checked every possible cell, no problem. In fact, that might even be better because people reading the code are going to say, oh yeah, well, okay, that checks it. Instead of relying on that extra step of mental reasoning that says, oh yeah, of course you only need to check the top row. So I don't know what's a better approach. So if we find that at position RC in the grid, if we find, if we don't find, no. How are we going to do that? If we find a dot, there we go. I had to check it, right? It's either going to be if we find a dot or if we don't find a dot. It was either one of those. Or, you know, we could do, if we find, you know, we find an X or we find an O. But that's the same as not finding a dot, right? So look at these are the, in my mind, I'm just sharing with you what I was thinking, okay, as I'm solving the problem. In my mind, I went through these 3 possibilities. I said, okay, what do we need to check for in this loop? Do we want to look for a dot? Do we want to look for the case that it's not a dot? Or do we want to look for the case that it's an X or an O? Well, then I very quickly in my mind realized that we don't need that because that's equivalent to this one, right? If it's an X or an O, then it's the same as saying it's not a dot, because there's only three possibilities. It's a dot, an X, or an O. So I could rule this one out. This one is out. Rule this one out. But what about these two? Then in my mind, I had to, I'm doing this quickly in my head as I'm talking, right? But now I'm slowing it up. Let's analyze this one. What happens if we don't find a dot?
Then you know every aspect of that row is filled with either an X or an O.
Huh?
So you would know logically that everything's either filled with an X or an O.
Not everything. This is only one RC.
Well,
We're inside the loop. Oh, I'm sorry. R is not. Is this that? I got that wrong. This should be a 0. Very sorry. That's a 0. At this point in the code, we don't know that everything. This expression here is only checking one pair 0C. So what action can we take if this one spot in the grid doesn't have a dot? Can you conclude anything about whether it's a tie or not?
If it's not a dot, then you just have to move on to the next one.
Yeah, so this doesn't look that good. You can't draw a conclusion about whether it's a tie. What about this one? Let's suppose for that one cell, let's suppose C is 2, okay? Let's suppose C is 2. Let's suppose grid of 0, 2 has a dot, okay? What conclusion can you make on the spot right now about whether it's a tie or not? It can't be a tie. There's another move. Isn't this a common theme? You recognize this is the same logic problem that we have almost in so many of our problems. You know, which one of these things to rule out and which one to use. You know, what you're looking for, what conclusions you can draw, like on the spot there without going any further. So we know that if we find a dot, can't be a tie. Can't be a tie. And let's suppose that we complete the loop and we never find a dot in row 0. What do we conclude? It's a tie because of this precondition, because we know that it's not a win for either of them. Every cell is taken up. It has to be a tie. That's when we return true. Oop. We have an assertion failure, line 27. I typed in a 3.
Should it be C is greater than 0?
I think I got the assertion wrong. Oh, I got it wrong, right? This should be, sorry, this is totally wrong. This is, C has got to be greater than or equal to 0, and C is less than or equal to 6. There you go. We got the assertion wrong. Three. Now it takes it. 3, 3. Up. Can't play there anymore. 4, 4, 5, 6. So there's no real AI. The computer's just taking a random move, right? That's a 1. 2, 3, 4, 6, 1. I don't want to lose. 3. I don't want to win either. 3, 2. What happens? I just typed in a 2. 2. Oh, so that's okay. Maybe I didn't hit it. So it's, I'm going to try not to win here. I could pick 1, right? 1. And 1, 2, 3. I better pick 4. And 1, 2, 3, 4. Better take this one. Computer wins. Wasn't paying attention. How did the computer win? Diagonal. I was not paying attention. Anyway, that's the end of that problem. I forgot last time to implement tie. And I wasn't paying attention. So that finishes the problem. I can look at your tic-tac-toe code that you're developing right now, and I can give you a critique of your work right now to help you along if you like that. You want to look at your code up here?
Sure.
Okay. Give me a few letters of your ID.
Just a few of the numbers of my student ID.
No, that's you, right?
Yes.
Okay. So we're going to look at Alfred's tic-tac-toe problem. And it's
under application ex1.cpp.
this one here, that one right there.
Yes.
Oh, that's it right here, right? Okay. So let's take a look. There's a draw board function. That makes sense because we have console programs. They're going to call draw board sort of over and over again. Here you have something, it's called square here, right? See, I would rename that to draw square or rename the data structure to board. Because now you have two different names. They're both good names. It's just why have two? It's better to have one. So you know that they're talking about the same thing. That's my first critique, my first a suggestion. So we got this square, and it's an array of char, and you're putting in the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so that's good. Then you've got the player character, which is an X, and the computer character, which is an O. That's good. Then we have draw board, and it looks like a really fancy draw function. And then we have things like, we're putting in these lines. There's a heading area. We're putting in these lines, and then we're outputting the character that's in a certain square. So this looks great. The draw board function looks great. And that's under application, right? Does this build right now?
Yeah, I believe so.
It does build. So start a game or quit the game, right? Collaborative terminal.
It's probably because I'm in it.
Go ahead and stay on.
Yeah.
Yeah. Some side effects, this is the first time I ever saw this. Some side effects are that the terminal view will only be as large as the smallest view of all the creators. Oh, that's why. Oh, see, that's why. See, that's what you see. I made this larger,
Yeah.
but it stayed small for you.
I
And
can get out of it if you wanted to see it
huh?
larger. You said I can get out of it.
No, no, no. Don't get out because I want to learn how to do this. Yeah, I want to learn about collaborative terminals and whatnot. The rest of the space is unavailable. Why don't you just expand the size of your terminal window so that, see, now we're the same. So note that this can also happen when the workspace is open in another window. To resolve this, right-click on the terminal and choose Detach Other Clients. Yeah, that's good. Pretty neat. So if I want to quit, I just pick 2. If I want to start the game, I pick 1. And now, oh, yeah, I gotta have to make it a little bigger to see everything. But anyway, maybe I'll put it up here. Can I do that? I know you're still in there, right? Yeah, maybe that's not going to work for us. So I'll put it back down here. And I'll open a terminal up here. So 1. That's a really nice output, really nice. So I pick 1. It's going to put the X in 1. That's good.
That's about as far as I've gotten so far.
Huh?
It's about as far as I've gotten.
I mean, it's great. This is great. And then you exit here, right? Okay. So it's very nice. What you have is just great right now. And now you got to move forward, right? So you have to decide what to do next. Well, you could stay in a loop and just let the X's fill in the board until you get a win, or you don't even have to check for a win. So you have to do something. You can't do the whole thing in one step, but you have to do something small at least. You need to take one step toward completion. So what is that one step? Do you have an idea of what it is you're going to do next?
I mean, I think after the first player puts in an X, for me, it's the first step, so we could potentially check for a win, but it also doesn't make sense because it's the first step. And then it would be the computer's move, and then they put in an O, and then we check for the win again, and just continue.
What do you want to do next? You can't solve the whole programming problem in the next step. You've got to make one tiny step forward. Right now, you printed the empty grid, the empty board, and you let the player, the user, choose a position, and you rendered the X in that position. That's what you have done so far. What little bit more are you going to do? And you can do a lot of different things. Let's take a look at your code first, okay? So the printing code looks good. The player move. So this means it's time for the player to go. So you're going to call this function player move. You prompt the player. You read in the choice. And you don't check for valid move. That's commented out. And then if the choice is 1 and square 1 is a 1, then square 1 equals the player. That looks all right. Oh, I see. Oh, also, you're returning an int here. What did you want to return from player move?
So basically, the intent was it's going to check numbers 1 through 9 that's on the tic-tac-toe board. And if number 1, for example, so if I as the user input 1, and square 1 has the 1 still there, then basically I'm going to input an X.
Yeah.
So I didn't know if that is considered an int or if it's just a void function or how that would play out.
Well, you're not returning anything, right?
No, I
So
mean,
you've
other than
implemented it
it's-
as if it were a void function.
Okay.
But see, like you commented out valid move because you incorporated that into this logic here.
Hmm.
So this logic, this is just a gut feeling I'm getting here, is that the logic you have down here is doing more than one thing. And it might be simpler if it only did one thing. This logic is checking to see it's a valid move and making the move. And when I did the Connect 4, I separated those into two separate activities.
And that's what I was looking at doing, and that's why I commented out valid move, because I wanted to make sure that the program still compiled. And then I was going to work into the valid move function, which was directly above that function.
Now let's see, the problem with this right now is that let's suppose that the choice is 1, right? But the square does not have a 1 in it. The square has an x, an O in it. So what do? Well, you don't put the x in square 1, right? But then what do? Don't you have to ask the player to try again? So how are you going to ask the player to try again? I want to try to complete the program under your energy and your thinking. And I'll just try to poke around at it a little bit rather than imposing my order or ideas onto you.
Well, I know I tried using a while loop, but then that didn't work out because that would make an infinite loop if it entered certain numbers or whatever.
Yeah.
So I know I can use that. And I feel like we would probably go like an if-else statement somewhere. I'm just not too sure where to put it.
Yeah, see, this is why programming is hard, isn't it? Has anybody finished this program yet without looking up the solution? No. Without looking up a solution, because there's many solutions. And I don't want to just show you I showed you my solution to Connect 4. I showed you the process that I used to get there. So here's the main. See, this stuff here, which is really nice. You made it pretty. The user interface is pretty, but I think you spent a lot of time making it pretty without getting to the core logic. See, that's my second criticism of your approach. But it is nice looking, and mine doesn't look good, right? So I know yours is great. But now we have this menu choice. By the way, this should be, it's like you wanted to be looping, right? You wanted to, after you play one game, do you want to play another game or quit, right? Well, see, once again, that's a logic problem in itself that you've layered on top of the core logic problem, which is just to get the game to work. So, and you haven't even completed that. An added layer of logic. Here's another problem. All programmers do this. Everyone. I have never met a programmer that doesn't do this. You are overly ambitious. You're trying to do more than you need to, and you think it's easier than it really is. Every programmer has that problem. Everyone. You ask them, a young programmer, hey, I need you to implement tic-tac-toe for me. How much time do you think? You say, oh, I'll finish it by the end of today. Then, depending on the age of that person, you would just maybe multiply by 10 or 20. Maybe it's going to take 10 days to get it done when you said a day. So it's always the case. It's a funny thing. It's just, I guess, a pattern or a weakness that you see in the psychology of programmers. So you have, And there's a term for what you're doing here. Because I'm like the client. I gave you a specification what to implement. But you're going beyond that. You're asking whether to quit the game and start the game, right? You're going beyond what I asked. So that's called feature creep. Feature creep is where people say, oh, wouldn't it be cool if we did this? Oh yeah, it'd be so much better. Oh yeah, let's do this. And then all of a sudden you're adding all this extra requirements, all these extra requirements onto your core requirement. And that increases the risk of the project. It increases the probability that the project will not be completed or completed on time, right? Same thing. So that's why, just to begin with, you've added extra. You know, the problem is hard enough to solve. And now I have to think, now I got to think, what would I do? All right, now I got to redefine the problem in my head, and add this extra activity onto it. I mean, it's hard enough for you. I'm like good at this, right? I'm like an expert, so I know how to solve the problem. But you're like new. You're trying to learn this, so you might want to set this aside and get your core logic running first, and then come back to this ex1.cpp, and then flush it out with what you need. So you're trying to do too much at the same time. It's the same problem with this function. You're doing two things at the same time. You're checking for validity of the move and making the move all in the same sort of soup of logic, whereas you should make that two different activities. Let's just keep it simple. I want to know if this is a valid move. That's all I want to know. I forget everything else. Just tell me if this is a valid move. And then I'll write a function. Valid move. Pass the move into there. Just tell me yes or no. Is that a valid move? Do you see how simple that is? And you're saying, well, nah, that's going to make the program long. Let me just do everything all at once here, you know. But then it gets confusing. So this is, in my opinion, a confusing sort of approach, because it's got two different requirements that don't need to be merged. There's no reason to merge these two requirements, these two activities together in the same step. Is there anyone else you want to look at? You guys back there? Anybody with tic-tac-toe code? You want to look at your code? No, that's okay. That's all right. Can you apply what I'm telling Alfred here? And he is nice enough to be the target of my stinging criticism. Thank you for that courage. But does what I'm saying now make sense to you? Does it seem to apply to you as well? Yeah. Okay. And once again, I'm not like I know everything, so I'm just giving you my opinion, and you develop your own understanding as you go along. I'm just giving you my feedback and my opinion. All right. So what else we got to do here? We have some more time. I don't really want to do this. You're not. If I just start typing it out and crafting it up, I want you to take that principle that I've just identified. That's to do with scope. Like, what are you going to do? Like, don't try to do too much at one time. Try to break it into small building blocks, and you put the one block on top of another. And one block shouldn't be overly complex or dependent on others. Reduce the dependency as much as you can. That's why here, what did I do? Oh, the valid move here. Remember I said here I was trying to decide, okay, I said, if C is less than 0 or C is greater than 6, then return false, right? So then I was expanding the concern of valid move. Here, the way I have the logic now is I'm just Valid move is just checking to see whether there's an open spot in column C. Some other logic is going to check that C makes any sense at all, like if C is -3. So I'm narrowing the definition of valid move here. I don't want to check too much. I'm going to let the calling code pass me a valid C. You know, not if it passes, I'm going to assume the calling code checks for C equal to -4 and rejects it and asks the user to enter in another number. I'm not going to get involved with that activity. Me, I'm valid move. All I'm going to do is assume that C makes sense, and I'm going to check to see if there's any available cell in that column. Now, I know that I use an assert here because maybe the calling code isn't going to pass me a valid C. But rather than incorporate it as a responsibility and returning false for a bad C, rather than assuming it as my responsibility, I'm simply going to check that the other guy took care of his or her responsibility before telling me to do my job. And that's why I'm using an assert here. So if the calling code has failed to do what they're supposed to do, then we're going to terminate the program in line 27 with this failed assertion. That's why I choose an assertion here instead of returning false for a bad C. Once again, it has to do with making those building blocks small, well-defined, easy to move around, easy to understand and reason about. So we still have a lot of time left. What about the final exam? Do you want to talk about that a little bit? Yeah, final. Okay. Because, you know, all of this, what we're dealing with here, this is like real stuff. This is like real learning. This is what you really need to do. This is what the long-term goal of this course and knowledge is all about, is learning how to program or solve programming type problems. So this tic-tac-toe problem is particularly valuable for that, and that's why it's such a great problem. But it's not really connected to your grade. It's only connected to your ability to do well in your career. But your grade is going to be based on taking the exam and answering those questions. So we have to spend some time on that as well. Now the reason before I gave a lot of points for this tic-tac-toe problem, right? I made it like really valuable because this was like the most important thing you could do in the class. So I put tons of points there. What did I do? Everybody is copying code they got on the internet. They understand nothing about what they're submitting. They learn nothing. And so that's why I just set, I don't know, was it 20 points for the, so it's not even worth going on the internet and copying the code and getting it into shape enough to submit it. It's not even worth that. And that's what it needs to be. But if you're interested in doing well in a career that's based on programming, then you should put lots of time and energy into this tic-tac-toe problem. All right, that's so much for lecturing about that stuff. Let's go to look at this final exam. Here is sample exam problems. All right, right there, rectangle class, number class. So I just have classes. Because did we have classes up here on the exam too? We didn't have this, right? So you need to have practice with the classes. Which one of these three do you want to look at really quickly? And we have one more meeting, by the way. We have a meeting on Monday.
Number class.
Which one?
Number class. That's the one I have issue with.
The number 2? Which one?
The number class. Yeah, I guess number 2.
The number class. Do you have a problem with that one?
Yeah, I don't know why I was having issues with it, because when I did the rectangle one, it seemed like I can.
Rectangle is not bad.
Yeah, it wasn't that bad for me.
With the rectangle class, I give you the test code, don't I? Well, for the number class, I don't give test code, but you have to invent your own test code. Let's just do this one really quickly. The number class represents integers. The integer value that it represents is passed into the constructor and stored in a member variable n, that's here. We have set value that sets the integer, the member variable n, to the number that the user code is passing in. Is prime function says true if the member variable n is prime or not. And is lucky is similar, is n divisible by 7. Returns true if the number it represents is divisible by 7. Let's go ahead and implement this and take a look at it. Do you want me to do it as if I were taking the exam?
Yeah.
Okay, let me do it as if I'm taking the exam. Let's do this. So here's the number class. Oh, wait, I think I have questions there. No, I don't have any questions, do I? I should have these questions, and I don't do that. Maybe I need to, there'll be something like this on the exam. There'll be questions. The first question might be, provide an implementation of the number class constructor. And the second question, provide an implementation of the set value function. I just have a whole bunch of these. This is what the final exam will look like. Provide an implementation of the, what else do we have there? Is prime and is lucky. And then provide test code that tests the is prime function of the number class. All right, these are typical problems, typical questions, okay? Let's do these. Provide an implementation of the number class constructor. Well, it'll look like this. We pass in an n, and we just initialize our member variable n to n. So you could do that. That's one possibility. The other possibility is to do this. This is called an initialization list. We don't need that. We could do this, n is n. In other words, the member variable n, that's this n, set it equal to the n that's passed into the constructor. And then there is yet a third possible answer. These are three possible answers. You could say, well, this confuses me. I'm going to change that to a k. So I don't have the same name as my member variable, and then I'll just set the member variable n to this value k being passed in. I mean, there's so many things you could do. You could also do it like this. Here's another variation. I'll do that. Let's suppose we use the k approach here. That's how it would look there. So you have four possibilities. Which one makes sense to you? You've got the value, that integer being passed into the constructor. The constructor's job is to initialize the member variables. There's one member variable, n. We got to set n to the value that's getting passed into the constructor. Well, let's give that variable in the constructor's argument list a different name than the member variable, so we don't have to be confused about this. Of course, we don't use a this for this either, right? But some programmers say, well, this is easier because it's just, I just know that if the argument has the same name as the member variable, then I know it's a straightforward copy. So this line 7, 8, 9, that's the most common implementation style that you'll see in code. But I think the recommended textbook for the class uses this form right here. Because for students that are just starting out, they get confused between the difference between the member variable and a function argument. The two different things. You got to copy one into the other, but then the whole thing becomes very confusing to new people. So they like to give those two things different names. But in real life, it's easier to have the same name. But that comes later, after you've been perhaps programming for a while. So there's 4 possibilities. What about it's the same issue here with the set value function. Now, set value is a void function. You've got to pass in the value you've got to set your member variable n to the value that's passed into the set value function. Once again, you can use the same name because it's meant to be a straightforward copy. So if you wanted to use this style, you can use that style as well. Those are 2 different possibilities. Which one is easier for you? There's only 2 possibilities here. This is not a lot of choices to make. Do you like the first one or the second one? The third one, what about the isPrime function? Well, isPrime will return a bool. You see that here? IsPrime returns a bool. Is the number I'm representing a prime number or not? So it's got to return a bool. And the number prefix is before the function name, by the way. So first I have to write bool, and then I write the class prefix. So, is n prime? Return true if member variable n is prime. I make that a sentence. See, there's no argument to the function because we have the data already sort of encapsulated and accessible through this variable n. So we just try all the different divisors. It's the standard logic that we've been practicing. If we find a divisor, if n mod I is 0, means we found a divisor, then we're going to return false. We found a divisor, n cannot be prime. The number we're representing is not prime because we found a divisor. If we go through the loop, we never find a divisor, we exit the loop without returning false, then we return true. And this will be the same for is lucky. I'll type it out here. So bool number is lucky we need that loop for I equals I equals 0 to all the way up to n minus 1, including n minus 1. If we find, wait a minute, we don't need a loop. What am I doing? It's not an is lucky array. I'm spaced out here. I know that students are going to make this mistake. Is n lucky or not? Well, we're going to take n and divide by 7. If n is divisible by 7, then it's lucky. If n mod 7 equals 0, then return true. Else return false. I'll do it all in one line there. I'm going to give you three different ways of doing this, or you could do it like this. If n mod 7 equals 0, return true. Else return false. Still not working. That took a while. So you could use this one or this one, but here's my favorite. Return n mod 7 equals 0. That's the one I like, that one there. That's the shortest. See, if n mod 7 is 0, we're going to return true. If n mod 7 is not 0, we're going to return false. So that does all the work we need right there. But it all has to do with readability. What's readable to you? So you could do any three of these. What about test code for is prime? Well, we've got this number class, and I'll create a number called 2, passing in a 2 to the constructor. And then we're going to assert that 2 dot is prime. I'll do it like that, equals true. And we just do a bunch of these. Well, we could call set value now. Let's call that number. We'll call it num. Then we have assert num. That's not right. I'm going to do num.setValue. Nah, I'm not going to do that. Change my mind. I'm going to call that 2. Call that 2. And I'll call this 4. And this should be false. You really need a lot more test code, but for the exam, for this particular problem, I would accept either this chunk, either both of these together or just one little chunk, just 2 lines right there. That's good enough for me. Because I don't want you to have to write a lot on the final. So you don't want to do exhaustive testing. Just want to make sure that you understand how to instantiate the class, and use it with an assert statement to form a test. Any questions with that one? Does that help or not? A little bit? It's still confusing, I'm sure, right?
Yeah,
Yeah.
it does help.
Okay. Yeah, see, the exam will do things like this. It'll ask these questions. Provide an implementation of the constructor for the number class, so on. That's this number class, and then this is the bean jar class and the egg carton class. One up here, this is the exercise 2, this one up here. Yeah, see, this is designed to be an exercise problem where you code it up with a main function and you work at home. And this is how that would appear on the exam as a question on the final exam. So you've got the bean jar class, same thing. You've got questions. Here's draw the UML diagram. Egg carton class. Here's some functions in the egg carton class. These are the questions. Provide an implementation of the add eggs function, for example. So these are potential exam questions. You might want to do these on paper. Number, bean jar, and egg carton. Do those on paper and then bring them and show them to me. Either today, and come to my office, or if I'm in the lab, you show them to me in lab, or else do it on paper over the weekend and then show it to me on Monday. And I'll tell you whether those are correctly answered for the purposes of the final exam. These are very good problems to work on. You don't need to code these up and build and compile and run them. You can just write down your answers as if you were taking an exam and then show them to me. And I'll tell you whether they would get full credit or not. Any other questions? I think we're out of time here. That's it.